गुड मॉर्निंग ऑल ऑफ यू। हम यहाँ एक ऑब्जर्वेशन देखते हैं। व्हाट इज दैट ऑब्जर्वेशन? See, if you draw a PV diagram, on a thermodynamic plane. Let's suppose this is a process, right? This is a process 1 to 2, and other PV diagram, same PV diagram, there is another process 1 to 2 upward axis, right? In this one, there is V1 and this is your V2. Similarly, there is V2 and there is V1, right? This is your maximum temperature, and this is your minimum temperature. This is maximum pressure P max, and there is minimum pressure P min. There is a maximum pressure P max, and this is your minimum pressure P min, right? And generally, this is your clearance volume, VC. See, the clearance volume is like that. There is a cylinder generally in IC engine. There is a piston, and piston will reciprocate inside the cylinder in between these two dead state, and this two distance is called a stroke, right? So to protect the piston head, to protect the cylinder head, we always give some gap between inner dead center to the piston head. That gap is known as clearance volume, VC. And clearance volume, and this is your minimum volume. Why? This is your minimum volume, right? Now, during this process, this is your work transfer, and during this process, this is your work transfer due to displacement of a boundary, right? But in this case, V2, in this case, V2 is greater than V1, but in this case, V2 is less than V1, right? So V2 by V1 is greater than 1, and here V2 by V1 is less than 1, right? Let's suppose this is your isothermal process, a reversible isothermal process, thermal process. Both, either this or this, both are the reversible isothermal process, right? So what is the boundary work. What is the work? In this case, if this is isothermal, then work is P1 V1 ln V2 by V1. In this case, work is P1 V1 ln V2 by V2, right? So in this case, V2 by V1 is greater than 1, so work will positive, and in this case V2 by V1 is negative, so work is negative. Hence this is work done by a system. Why? Because work will develop due to expansion, and this is your see, when work done by the system, this is your clockwise direction, and work done on the system is anti-clockwise direction. So work done by the system clockwise, work done on the system anti-clockwise, right? So clockwise process is work delivering device, anti-clockwise direction, the device is work absorbing device. Okay, now this is clear. See, this is your minimum value, which is a clearance volume. This is the maximum pressure. This is your minimum pressure. This is your maximum pressure. This is your clearance volume. Right. What is the clearance? The clearance volume and maximum pressure minimum all are आप समझ लेंगे आप जब नेक्स्ट पावर प्लांट के सब्जेक्ट में जाएंगे ना, तो ये चीज पूरा आपको डिटेल से मैं बताऊंगा आपको. Now, see, there is one question. This is asked in, I think, 2005. Very important question in GATE. Why this question is very important? Why? Because many books give the wrong answer and many YouTube channels. I try to justify it. See, before that, if you have a cycle, see, read the question first of all. A reversible thermodynamic cycle, that means this is a cyclic process. That means initial and final point is same. That means this is a cyclic process containing only 3 process. ये साइकिल कितने प्रोसेस हम जानते हैं कि मिनिमम नंबर ऑफ प्रोसेस फॉर ए साइकिल इज 2, मिनिमम, मैक्सिमम तो कुछ भी हो सकता है. सो देयर आर 3, द साइकिल विच कंस्टिट्यूट बाय 3 प्रोसेस. उसमें से द एंड प्रोड्यूसिंग वर्क टू बी कंस्ट्रक्टेड, मतलब उसमें से एक प्रोसेस जो है वो वर्क प्रोड्यूसिंग है. देयर इज वर्क एंड प्रोड्यूसिंग ए वर्क टू बी कंस्ट्रक्टेड, मतलब 3 प्रोसेस में से एक प्रोसेस आपका वर्क प्रोड्यूसिंग है. राइट. सो दिस इज योर, एंड साइकिल will contain this process. There must be one isothermal one isentropic, and one is the maximum and minimum pressure and clearance volume, and no polytropic will consider. polytropic आपको consider नहीं करना. वैसे भी मैंने बताया कि generally cyclic and polytropic process consider हम नहीं करते in general जब तक कि दिया हुआ नहीं है. See, if we design a cycle for these two processes, that means in which one is isothermal and one is isentropic. Isentropic process is nothing. Isentropic process is nothing. It is a reversible adiabatic process. Reversible plus adiabatic process, right? Reversible adiabatic process. That means one process is reversible isothermal process, one process is reversible adiabatic process, and one process is in which fixed maximum and minimum pressure and clearance volume, right? So for that we construct a possible cycle. If this is your PV plane, P and P. So first cycle possible is that if you assume like that, this is your constant volume, and we assume like that, okay? Assume this is 1, 2, 3. This is your cycle. See, if you put a cross here, this is your n equal to 0, and this is your n is equal to infinite. So in this direction k will increase. So this is your isothermal process. This is your isothermal. That means 1 to 2 is isothermal, 2 to 3 volume constant, and 3 to 1 reversible plus adiabatic. That means isentropic. Right. See, what is the condition? There must be one isothermal. This is your isothermal 1 to 2. There must be a one isentropic 3 to 1. There must be isentropic. And third is your maximum and minimum cycle pressure. This is your maximum pressure, and this is your minimum pressure, right? And this is your clearance volume, VC. Okay. So one possible cycle is this, like this one. Now other is that if you draw a PV plane like that, P and V, all is the reversible cycle, and you construct like that. This is your volume constant. This is your process, one process. All are clockwise. Why? Because there is a work producing. So this is your pressure constant, and construct like that. Okay. So in this case, what is the process? Put a cross mark here. This is your 1. This is your 2. And this is your 3. This is your clockwise cycle. That means work will produce. So this is your n equal to 0. This is your n equal to infinite. So this is your again 1 to 2, this is your n equal to 1 and this is your n equal to gamma. So 1 to 2, 1 to 2 a reversible isothermal process, 2 to 3 pressure constant, and 3 to 1 isentropic, right? Again we draw another process like that, another cycle, pressure and volume, right? If we draw this like that, if this is your constant volume, and you draw like that, right? 1, 2, 3. This is your process cycle. You put here the cross mark. So this is your n equal to 0, n equal to infinite. So this is your n equal to 1 and this is your n equal to gamma. So in this case 1 to 2 isentropic, 2 to 3 isothermal, 3 to 1 volume constant. Now the last one is that if you draw a thermodynamic plane like that, and if you draw this is your volume constant and this is your pressure constant, right? Now what is the process? Put a cross mark here. So this is your n equal to 0 and this is n equal to infinite. So this is your n equal to 1 and this is your n equal to gamma, right? So in this case 1 to 2 pressure constant, 2 to 3 isentropic, 3 to 1 isothermal, right? See, the question is a reversible thermodynamic cycle containing only three processes. All are the three processes producing work to be constructed. Producing work. This is all producing work, and in which there must be a must be one isentropic, must be one isothermal, maximum and minimum cycle pressure and clearance volume, no polytropic, right? So for for this condition, according to this condition, the number of possible cycle is 4, and your right answer is okay, happy. But this is wrong option. Many would given like that. क्यों ये गलत क्यों है? क्योंकि आपने ये चीज नहीं देखा. The constraints are, इसमें ये कहा गया है कि constraint है, that means there must be one isothermal, must be one isentropic, must be minimum cycle pressure and clearance volume, maximum minimum pressure cycle, maximum minimum cycle pressure and clearance volume. So you draw this cycle, but this is wrong. This all drawing are correct, but when it is correct, when constraint are not given, but there is a constraint. What is meant by the constraint? See, many book, I am reading, some book, they have 4 cycles. That means option number 4. But by they miss the constraint. That is, 2 process must be isothermal and isentropic. 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 2 process must be isothermal. One is isothermal and isentropic. But see, in this cycle, what is that? Volume constant. That means isothermal volume constant isentropic. Isothermal volume constant isentropic. Isothermal pressure constant and isentropic. But these 2 are the repetition of this. This is also isentropic, isothermal and volume constant. Isothermal, isentropic and volume constant. This is also isentropic, isothermal and pressure constant. So if the constraints are given, these 2 cycles will not be included. Why? Because these and these and this and this, they are the same. Why? Because this is also isentropic, isothermal volume constant, isentropic, isothermal volume constant. There are isentropic, isothermal and pressure constant. This is also isentropic, isothermal and pressure constant. So the correct option is 2, only 2 cycle. If the constraint is not given, अगर यहाँ पे हमारा ये कहता है the constraint are, अगर constraint नहीं रहता, यहाँ constraint दिया हुआ है, there is a constraint, अगर constraint नहीं होता, ये टर्म अगर नहीं होती, तो हमारा 4 प्रोसेस हो जाता, 4 साइकिल हो जाता. दिस इज करेक्ट. बट with their constraint, only 2 cycle is possible. So this is your right option. Okay. Thank you very much.